G'day everyone. In this video we're going to be looking at the distance between 2 points. So we're going to be using these 2 points for an example. And we're going to be looking at the midpoint. What's the point in the middle of those 2 points? And we're going to be looking at the normal, and I'll explain what that means when we get to it. So first off, the distance between 2 points. Okay, so here we've got a linear line of y equals 2x plus 5, and there it is. And we've got these 2 points here. So this bottom one is minus 2, 1, and this one here is a minus 1, 3 for that coordinate. And we want to know the distance between those 2 points. Well, it's not that hard. All you've got to remember is a little thing called Pythagoras. Pythagoras' theorem, which you may remember to be c squared equals a squared plus b squared, or a squared plus b squared equals c squared, if you want to write it the other way around. Now what that means is, if you have a right angled triangle, like this one here, whoops, drawn badly, let me try again. If we have this right angled triangle, oh, come on. That right angled triangle here, this side we'll call A, this one B, and C here is the hypotenuse, okay, and it's a right angled triangle. Then this tells you the length of that hypotenuse C. So here C must be the hypotenuse. So for our example, we can see that A here is a distance of 1, and B is a distance of 2. You can tell that fairly easily. And so using this formula for us, we have the c squared is 1 squared plus 2 squared. So c squared is 1 plus 4. C squared is 5. So c must therefore be the square root of 5, whatever that is. Now we also like surds in methods, so we're going to keep it as a square root of 5. So there we go, that is the distance between these 2 points. Now, let's make a general sort of statement about doing this. Imagine this point, we just called it x2, y2, and this point we'll call x1, y1. So to get the length here of 2, well, it's the change in y. It is the 3 minus the 1. And to get this other point, it's the change in x. It's minus 1, take away minus 2. So in other words, yeah, so there you go. So if we wrote these down, we could say that our b here is actually y2 minus y1, and our a is actually x2 minus x1. So we can write Pythagoras' theorem again using this. So we could say c squared is actually our x2 minus x1 squared plus our y2 minus y1 squared. And if we wanted to, we could just say c, which is the distance between points in this case. So we square root everything, and we could write it like this. So there we go, there's a formulaic way to find the distance between any 2 points. All you've got to do is put in your x2, y2 coordinate and your x1, y1 coordinate, and you will find the distance between those 2 points. Alright, next up we want to find the midpoint between these 2 points. Okay, the midpoint. So just sort of visually we can see the midpoint's roughly here. There it is. So to find the midpoint, it's going to be the midway through there is our x coordinate, so there, and our y coordinate is going to be halfway between our 2 y coordinates, it's going to be here. So you should be able to see fairly easily that it's going to be minus 1.5 or minus 3 on 2, and here it's 2. So we can see that our midpoint's that. So let's see how do we actually find these midpoints? Well, it was to find the x coordinate. It was x. It was the average of our x coordinates. In other words, it was this one here is our average of x2 and x1, which is how we got this. And to find this one, it's our average between y2 and y1, our average between 3 and 1, which is 2. So in other words, our x coordinate is the average of our two x coordinates. So that's x1 plus x2 over 2, because that's our average of two numbers, is divided by 2. And for y, our average of our y coordinates. There we go, and that's all there is to it for finding the midpoint. It's the average of your x coordinates and the average of your y coordinates finds that midpoint. So there you go, jot that formula down. It will be helpful for finding the midpoint, just using averages. So there you go, fairly simple, finding distance or finding the midpoint between any 2 points. And the two key things we use are Pythagoras' theorem and use averages. So there you go, if you remember Pythagoras and you remember how to do your averages, you should be totally fine. Okay, last thing for this video is talking about normals. Now what the normal basically means is a bit that is perpendicular to any point. So let's think about this point here. A normal will come out from it a bit like, let's see, a bit like that. Sorry, that's supposed to be a straight line. It's a bit of a terrible job. There we go. And it's perpendicular, which means that's a right angle there. And we want to find that normal. There you go. So, in order to find the normal, we know that, let's call this one here, or the equation of this normal is going to be y equals mx plus c. But so we don't confuse it with this one, we'll call it m2 for gradient 2, because 2 is our m1, gradient of the first line. So for normals, they have a gradient so that the gradient of the line that you start with times the gradient of your normal is equal to minus 1. That is the really key point. That is the thing you should write down right now, and remember. The two gradients multiplied gives minus 1. So our gradient 1 is 2. So here we have 2 times m2 equals minus 1, which means our m2 is minus a half. So the normal equation is this, minus a half x plus c. Now to find any equation, we just need to sub in a point. And the point we sub in is this one here that we know, the one point we know, which is minus 1, 3. Minus 1, 3. So we'll sub in minus 1, 3. I'm just going to write minus 1, 3 here. So 3 for y, minus a half, minus 1 for x, plus c. So 3 equals positive a half plus c. So c is 3, which is also 6 over 2. Take away a half, which gives 5 over 2, which means our final answer is, y equals minus a half x plus 5 on 2. So there we go, there's our equation of the normal. Let's review how we got it. We found the gradient of it by doing this, and then we just found that one point that we know for the normal, subbed it in, and we wrote our final equation. So there we go, that's all we did for normals. So have a go at finding some normals. And that's it for this particular video. We found distances, midpoints, and normals. Best of luck, and see you next time.